For thousands of years, human agriculture has relied on visual observation. We look at a plant, guess what it needs, and hope for the best. But there is a biological lag to this method. By the time you can actually see a yellowing leaf or a drooping stem, the internal damage to that plant is already severe. This is where artificial intelligence steps in. It replaces human guesswork with what engineers call a closed-loop system, a setup that continuously gathers and acts on environmental data without waiting for a human to notice a problem. By closing that loop, we stop treating plant care like a subjective art. We turn the garden into a highly precise digital nervous system. Before an AI can take any action, it has to accurately read the plant's current state. This is the sensing phase. Today, computer vision apps are trained on millions of crop images. You point your phone at a leaf, and the AI instantly cross-references subtle discolorations to diagnose a specific disease, often catching things faster and more accurately than a human expert. This animation shows vapor pressure deficit, or VPD. AI uses metrics like this to track environmental stress we cannot see, measuring the balance between ambient temperature and relative humidity. Using smart sensors, this data is fed back into the system 24/7. The plant is now constantly communicating its exact biological needs. There is zero room left for human assumption. But raw data on its own is useless. You need a brain to process those numbers and make a decision. For a home grower, consumer AI tools analyze your site's specific microclimate against hardiness zones and local weather patterns to suggest plant pairings that are optimized for your soil and sun exposure. At the commercial scale, the decisions get much more complex. Take the Alpha Garden project, an automated testbed developed by researchers at UC Berkeley. This graphic represents their real pipeline. Before touching a physical leaf, the AI runs the garden's current state through a digital simulator, testing thousands of potential watering and pruning strategies. It maps out every outcome, eliminates choices that stunt growth, and selects the winning strategy. Because the AI identifies failure points in a digital environment first, it can deploy the specific pruning or watering policy that the simulation predicts will lead to the highest possible yield. That brings us to the final step of the loop: actuation. The AI now has to translate its digital decision into a physical intervention. In a smart home grow cabinet, the system automatically adjusts the LED light spectrum or opens a mechanical valve to dispense exact doses of liquid nutrients. In the commercial space, the Alpha Garden utilizes a gantry robot that receives those simulated pruning decisions and physically cuts the plant canopy all on its own. When researchers put this to the test, the automated system perfectly matched the human experts in both canopy coverage and plant diversity. But while the visual quality was identical, the AI system achieved a 44% reduction in water usage. By automating every stage of the sense, decide, act loop, we move from simple survival to a state of resource efficiency, where plants thrive in a precisely engineered environment. The data is clear. AI proves it can grow a superior plant while maximizing resource efficiency. But handing our agriculture over to machines comes with a profound socioeconomic and ethical cost. If we rely entirely on algorithms, we risk losing local intuition and the manual connection to the soil passed down over generations. We also face the very real risk of corporate control. If farmers and home growers become dependent on proprietary algorithms and subscription platforms just to keep their crops alive, they lose their autonomy. And then's the physical fragility of the system itself. A highly optimized, fully automated harvest is incredibly vulnerable if a server goes down or internet connectivity is lost. The smartest future of agriculture is a collaboration. We let the AI handle the micromath and the daily diagnostics, and that frees us up to focus on the overarching strategy, the health of our communities, and the joy of the harvest.